And now, for Ryan Veenstra from the Cesium Bentley team, rapid landscape and visual impact assessment workflows using Cesium and open data. Come on up. Yeah. Give him a round.
Cool. Okay, so the technology concept I'm going to be talking about today was provided by Matthew Walker from Umwelt Environmental and Social Consultants, and happy to be talking about it on Matt's behalf. Okay, so what is Landscape and Visual Impact Assessment, or LVIA, as I will call it? It's a process used to evaluate how a proposed development might affect the landscape and the views that people might experience once that thing is built. The typical process is something like this. Go on site, take a bunch of photos from key vantage points. The proposed design, in this case wind turbines, is overlaid onto those photos accurately. Now this is not meant to be an artistic impression, it's meant to be an accurate representation that can be used to make decisions around these projects and how they're going to impact the community. Now there's some challenges with LVIA. The cost is one. It needs site visits for those images, particularly if they're remote projects. The time that it takes to produce them, especially if a new site visit is required, it's not very reactive to questions that might be had during the project. The workflows to make sure that they maintain accuracy are important. And the outputs are ultimately static, right? You've got one image. What if you want to move 20 meters down the road or turn to the left slightly? You can't really do that with an image. So Umwelt wanted to use real-time 3D to try and improve this process. To start with this, they wanted to build a solution. They needed accurate data. So for this project, they were able to source high-quality aerial LiDAR and digital elevation models from open government data portals. And that open data was key to reducing project costs and making this happen in the first place, as they didn't need to commission a bespoke survey to produce their initial digital twin. So the data is downloaded, uploaded into Cesium Ion, and turned into both terrain and point cloud 3D tiles datasets. LiDAR is particularly important to represent the tree canopies of the environment, which we'll see later, are crucial to understanding those sightlines. They use the Unreal Engine to stream in the 3D tiles and then place the wind turbines at accurate locations using the project design data. This gave them a digital twin that they could be used as a basis for an interactive tool. Okay, so this is the tool that they've used. They've used blueprints, no software, no coding has been used to produce this app. They built an application around their digital twin. Stakeholders can fly to the project location, such as the project site. They can turn on and off different layers like the point clouds and get a sense of what this is going to look like. From here, they can fly down to the local townships, the places of importance, and then have a street view-like tool where stakeholders can fly down onto the ground at pedestrian height and get an accurate sense of what the sightlines are going to be like from that location. And you can see here the point clouds are absolutely crucial in understanding that, hey, from this view, wind turbines are actually quite covered up. When you're just using that elevation model, it's not really that accurate representation. And you can see here, this is a crucial tool for that stakeholder engagement on contentious projects like this. Lastly, the exact position of these images are stored down the bottom here, latitude, longitude, the heading, so that these digital representations can be combined with the traditional photographic workflows moving forward. So what did Umwelt find by using this process? Lower costs, so open data meant they didn't need to procure data up front. It also meant fewer site visits, especially early in the project, where these sorts of questions might be asked regularly. That faster delivery enabled the tool to be used responsively throughout the project, so that if someone wanted to fly to a particular location, the digital twin is there, ready to go. It's a very quick question to answer. The framework they've built is reusable, so really all it means is they can put new data in, use the exact same blueprints, and they've got another tool they can deploy on a different project. And ultimately, by creating a tool with faster turnaround times, more responsive use cases, they've been able to improve project outcomes by helping answer some of these questions much earlier in the project lifecycle and more often. So I think that's it from me. Any questions, feel free to reach out to Matt, that's his details, or find me at the conference. Thank you.